Well, hello everyone. Welcome back to AstroNights. If you're joining us again, it's great to have you back here. If you're joining us for the first time, um, thanks for spending some time with us. We have a great presentation planned for you again tonight. We're very excited that you chose to spend a little bit of your weekend here with us. Our presentation is going to be about 20 minutes in length, after which we'll be able to address a few of your questions. Those of you participating on Zoom can post a question via the Q&A window. Be sure to hold your questions until the very end because it just might get answered during the presentation itself. If you're joining us via YouTube Live, you should know that Q&A is not available on that platform, so just sit back, relax, and enjoy the program. Whether you're joining us on Zoom or YouTube, we recommend taking a moment to locate the full screen mode in your app for the best AstroNights viewing experience. All of the websites and resources that we'll be discussing during our program tonight are going to be available on our website. So you don't have to worry about rushing to write anything down. Just relax and enjoy the program. Those links will be available for you following the program whenever you're ready. You'll be invited at the end to complete an online survey at the very close of the program, and we hope that you will take a moment, just a few moments, to share your thoughts with us, because we do use those would use that feedback in the development of future programs. And now I would like to introduce you to our presenter, Mary McDonald. Mary is the Planetarium Programs Manager at the Framingham State University Planetarium. And as usual, I know that she's very anxious to get started. So Mary, take it away.
Thank you, Bruce. Can you see me, Bruce?
Yes, I'm seeing you. Yes, I am.
Strange. I don't see myself.
Oh,
Okay.
I'm seeing you. You're just fine.
Well, thank you very much, and welcome everyone to AstroNights. Yes, my name is Mary, and I'm going to be your guide today. We're going to start, as usual, with a question for everyone. So I'm going to put that question up on the screen. So this is our question. Those of you that are sitting together at home, watching and participating, we encourage you to ask each other and talk about it. So this is the question: what can we learn about stars by studying their light? Select all that apply. So there's probably more than one right answer. And for those of you on Zoom, I'm going to go ahead and share this as a poll. So you can enter your answers, what you think is the right answer, or multiple right answers. So the poll is launched on Zoom. I'm going to give you about 30 seconds to put in your answer and hit submit. All right, we've got some answers coming in. And I'm going to end polling in just a moment, but I hope that everybody is still just talking about this. What of the following things can we learn about a star by studying their light? All right. So the most common answers that we got were what it's made out of and how far away it is. Oh, yeah, those were the two most common answers. People did not select all of them. So if at home you had some other thoughts, there were several that were not selected. But I will tell you that we were debating this a little bit, but technically the answer is that all of these are true. You can learn all of these things about stars by studying their light. Isn't that amazing? we just look up at them as just little points of light in the sky. But just by studying their light, you can learn all of these things. You can't learn it for every single star. Some of them are too far away. Some of them are too small or too dim. But for some stars, you can learn each one of these pieces of information. Some of them are a little bit easier than others. For example, what color they are, you can figure that out with your eyes just by looking at them. But some of them, like what they're made out of, you need a little bit more advanced technology to do it. All right, so that's going to do it for our first poll. And now it's time to head over to look at our night sky. And as you might guess, we are going to talk a little bit about stars tonight and some different things that we can learn about them. It's been a little bit tricky to see the stars recently. Even though the weather has been lovely, it's been nice and warm, we want to be outside. Unfortunately for us here in the Atlantic, it's also the beginning of hurricane season. So it's been cloudy a lot, rainy a lot, but hopefully you get a nice clear sky sometime soon and you can get out and look at the real thing. All right, so I'm gonna stop my video because you no longer need to look at me. It's time to just look at the sky. All right. Okay, well, I hope my video's gone. Anyway, the sky you are looking at is the sky that you are going to see tonight, June 12th at about 8 o'clock, a little after 8. And as you can see, the sun is still out at 8 o'clock. We're actually coming up on a very special day of the year. We're coming up on the summer solstice. So I actually have a special announcement to make, and I'll talk more about this later. We're going to have a special AstroNights next week on Friday night. Even though we usually only do it bi-weekly, we're going to have one next week to tell you a little bit and just sort of celebrate the summer solstice. There's many, many names for the summer solstice. Some people call it the longest day of the year. It's not quite the right way to say it, but it is the day we have the longest amount of sunlight, and therefore the sun sets very, very late. We're very close to the summer solstice right now, so we do still have the sun out at about 8 p.m. So now we're going to let some time pass. We're actually going to have to wait until about 10 p.m. to get a really nice dark sky. So hold your horses. We're going forward in time to 10 p.m. and it's Friday night, summertime. You can stay out till 10 if you want to go outside. All right, getting nice and dark. And let's now stop. It is 10 p.m. So what we're going to do tonight is we are going to turn towards the north and take a look at some of the stars we can, well, actually we're going to start taking a look over in that part of the sky. We're going to turn towards north. Hopefully this doesn't make you too dizzy. Are we turning the right way? Yes. We're going to take a look at something that we looked at in a previous AstroNights. Now, I'll tell you more about this later, but you can see previous AstroNights episodes. We have them all available on our YouTube channel and on our website. They're all linked there. So I might mention some things that have come up in those, and you can catch up later. So one of the things we've looked for in the sky was a very familiar pattern of stars known as the Big Dipper. And in that episode, we talked about how you always need to look towards the north for the Big Dipper. So we are looking north now, and maybe you saw that episode. Maybe you just know from somewhere else what the Big Dipper looks like. But if you think you know what it looks like, see if you can find it here in the northern part of the sky. All right, 10 more seconds looking for it on your screen, that is. And now I'm going to point it out. Oh, I've got to get my pointer going. right up here in the north, you got to go up, 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 up. And here we are, the 7 stars of the Big Dipper. And there we have it. Now you might have noticed, or I don't know if you can tell in this screen, it's actually pretty high up in the sky. It's almost directly overhead. So I'm going to point out a spot in the sky, a particular place. It's not an object, it's just a spot called the zenith. Oh, there it is right there. The zenith is the place that is directly overhead. So if you tilted your head all the way back, you would be looking at the zenith. And I wanted to point that out because the other pattern that we're going to be looking at tonight is very close to the zenith as well. So if you want to kind of follow along out in the real sky, you want to go out, look for the Big Dipper, look straight up, and that's the region we're looking in. So just sort of to the northeast of the Big Dipper, we're going to look for a funny little kind of kite-shaped thing over here. It's not the easiest to find pattern, but I'm trying to point out to you where in the sky it is. We started with the Big Dipper, and it's up here way up high in the sky, and there's this kind of little funny rectangle kite. And this is part of a constellation called Hercules. Now, I do have to admit to all of you that this is not one of the easier constellations to find in the sky. It's not the hardest, but it's not the easiest. So we're going to be looking, we're not really too interested in the pattern. We're going to be looking in this part of the sky for another object. And this is a great example of kind of what are the constellations really good for? Well, one of the things they're good for is kind of making a map of the sky. It gives you a place to point at in the sky. You want to explain to someone where you're looking. You say, I'm looking in the constellation Hercules. That's the part of the sky I'm looking at. And finding these patterns can help us to find other things in the sky. And sometimes when a really cool new object is discovered, sometimes it will be named after the constellation that it was found near. So today, we're going to be looking at an object that was first observed in 1714 in this region of the sky, and it is now known as the Hercules cluster. So I have to remind myself where to look. So it's located in Hercules, kind of, so between these two stars, Zeta and Eta Hercules. This is more for me to point them out, okay? So it's kind of right on the line between those two. Now, of course, the line is imaginary. It doesn't exist in the real world, but that's sort of where we're going to be looking, somewhere along this line here. And so let's go ahead and zoom in on this region so that we can get a better look at this part of the sky and see what was found there. Ready? Let's all get a closer look at the Hercules cluster. Well, let me leave Hercules up for a moment. All right, tell the person next to you, don't tell me when you start to see it. Okay, there's something kind of interesting. Zooming in a little bit more. And here we have it. Okay, so this is the Great Cluster in Hercules, the Great Globular Cluster in Hercules. That's what it's called. As I said, this was first observed in 1714, you know, when they had not the most advanced equipment. So it's something that was not too hard to observe. Before we say any more about what this object is, I would like you to ask each other again, what do you observe here? What do you notice about this object? And once again, for those of you on Zoom, I do have that same question in the form of a poll. So here's the poll for those of you on Zoom. And I just turned up the brightness a little bit artificially. Unfortunately, that's not something you can do in the real world. So everyone who's on Zoom, we have some questions for you. The questions are, by the way, what does a shape look like? Does it look round like a ball? Does it look like a football? Does it look lumpy like a potato? Is it a spiral? Does it look like something else to you? And then the next question, this is the one I'm really interested in, is what colors do you see? And pretty much all the colors are options. So do you see any of the colors, red, orange, yellow, blue, green, purple? Which of those colors do you see? And I know that you might, after the first poll question, you might be tempted to think it's everything's the right answer. That's not always the case. Okay, so I'm going to end the poll. If you're still working on it, submit your response. But the most common, we didn't see a lot of different colors here, so we didn't have people saying they saw all the colors. The most common color that most people reported seeing is yellow. So that's interesting. The shape, people had different ideas about the shape. I think, you know, it's kind of hard to compare it to something on Earth. But what I really want us to notice, and it's hard to say it in a poll form, is that there's a lot of stars really close together here. That's what we really want to notice about the Hercules cluster. And then the other thing we noticed is that we all noticed the color yellow. So that was the most common color that people reported on. But the most important thing I want to point out is that we all mostly see one color. We see a lot of stars appearing the same color. And by the way, now it's time for me to tell you a little bit about this object. So it's called the Hercules cluster, and it's of course a cluster of stars. I realized I haven't said that. So you're seeing a cluster of stars all really close together, and they all have very similar color. Most of them, people pointed out, have kind of a yellowish color. So that's a clue to us. The fact that all of the stars are a similar color, or most of them, that's a clue that these stars are really similar in a lot of ways. And astronomers, you know, they go beyond just looking with their eyes. They use tools, they use technology to study that light even more, and they can learn a lot more information. So we now know that these stars are not only the same color, they are also mostly the same age, and they are all mostly very old, much, much older than the sun, and in fact, older than most of the stars in our galaxy. So we're seeing this cluster of stars all really close together. It's obviously some kind of, there's some kind of relationship between them. This is some kind of massive object, bigger than a single star. So the question is this object, which we call a globular cluster, is it another galaxy? And the answer to that is no. And the reason we know that is because we can also figure out from the star's light how far away they are. And we have figured out that this cluster of stars is far away. It's pretty far away, but it is still inside our galaxy, inside the Milky Way galaxy. So distant galaxies are much farther away. All right, so we're going to talk a little bit more about the Hercules cluster and its place in the galaxy. So bear with me for just a moment. We are going to zoom back out, I think. No, maybe we won't zoom back out. We're going to stay here for just a moment. And I want to show you a diagram, not of this cluster, but I want to show you a diagram of the entire Milky Way galaxy. And let me zoom back out a little more so we get a better look. So this is just a diagram here of the Milky Way, or any galaxy really. And you can see that it has this disk here. So we mostly think of looking at a galaxy the other way, where we're kind of looking straight down at the top, and we see that spiral. We're looking at it from the edge. So we're seeing the edge of the disk here, And then in the center, there's a big bulge of stars. Sorry, I don't want to distract you with the Hercules back there. In the center of the galaxy, there's a big bulge of stars, the galactic core, and then around it is known as the galactic bulge. And then all around it, you see this area is known as the galactic halo. And it's not flat like a pancake, it's round. And it's full of these things called globular clusters. So you can see all of these little or yellowish things around the outside of the Milky Way galaxy. Those are globular clusters, and Hercules is one of them. The Hercules cluster is one of these. There's about 150 known globular clusters. So I'm going to zoom back out because I'm not sure that you have the best view of this. Yeah, there we go. So now we can see this diagram a little bit better. The galactic halo is this spherical region around the galaxy, and it's full of globular clusters. And they seem like they're a little bit apart, but they're actually orbiting in these giant big orbits around the center of the galaxy. So they are very much a part of our galaxy. Like I said, we have over 150 known globular clusters orbiting the center of the Milky Way, and we have seen globular clusters in almost every galaxy we've ever observed. We know that they are mostly full of very old stars, and there are some that believe they may have actually formed before other parts of the galaxy. So they're really interesting, and we believe that studying globular clusters can teach us a lot about how the galaxy itself evolved. So since we've taken a nice look at the Milky Way here and all of these different parts of the Milky Way, I thought it might be nice to take a look at more parts of the galaxy as we can see them in our sky. So we've zoomed back out for a view of the night sky. And just so that we're oriented, I'll point out Hercules again. And the Big Dipper is higher up, or it's behind us. We can't see it too well. So most of the stars we can see here, they are a part of, or all of them are a part of the Milky Way. And they're mostly all located in the disk. And you can even see more of the disk. You can see part of the gas and dust that make up the disk in the night sky. But you usually cannot see this because of light pollution. So you need to be in a place where the sky is really, really dark to be able to see the Milky Way. But luckily for you, you are at AstroNights, which means you can see anything. So we're going to make the Milky Way visible. There it is right there. And actually, we're going to go ahead and turn up the brightness of the Milky Way to a totally ludicrous level. There we go. So interestingly enough, this is a really good view of the disk, and in the region right below Hercules is actually the area where we find the center of the galaxy, the galactic bulge, where there's a lot more stars, a very dense area of stars. But even if we could see the Milky Way this bright in our sky, we can't really see the galactic center too well. It looks a little bit brighter, but unfortunately, our view of the bulge of stars is pretty much obscured by these black areas. And these are big clouds of dust and gas in this region that are so thick we can't see through them. So the light doesn't pass through them, and we therefore can't really see what's going on. However, if we could see the Milky Way in a different kind of light, we would be able to get a different view. So we're going to take a look at the Milky Way in a very different type of light known as infrared. And in this is the type of light that's very important to our lives. Our eyes can't see it, but we can build telescopes that can. So with this view from an infrared telescope, we can clearly see the bulge of stars here at the galactic center. And the infrared light from those stars is able to pass through the dust. So looking at our universe in different kinds of light is really important. And it's really one of the most important pieces of technology we have in astronomy. But let's go back to that visible light. And I want to remind everyone that, oh, that's just ludicrous. Huh, this, okay, never mind, there we go. All right, so I want to remind everyone that even with invisible light, you will probably not be able to see the Milky Way in your night sky because of light pollution. So light pollution is another concept that we've discussed in previous AstroNights, which I invite you to check out later. But you might be wondering about the Hercules cluster, what we talked about tonight. Could you see that in your night sky? Again, you're going to have a tough time if you live in an area with light pollution. But even in a dark area, the Hercules cluster is going to be difficult to see with the naked eye. You may be able to spot it with binoculars or a small telescope, and we actually have some advice on how to do this on our website, which we're going to take a look at in just a moment. And if all of that fails, and if you're with us here in Massachusetts and the weather just is not cooperating, we can actually give you some advice on how you can control robotic telescopes that will allow you to take beautiful images of objects like this. And the telescopes are located in places that have clear skies more than we do. All right, so that's actually a good time to take a break, and I'm going to take you on a little tour of our website. But don't leave us. If you have a question, about anything that's come up during our program today, we invite you now to enter your questions in the Q&A window. So those of you on Zoom, there is a Q&A window. You can go ahead and enter any questions you may have. And while you're taking your time to do that, I'm going to, as I said, give everyone a little tour of our website. So let me take you to the front page. Here we are. This is our website for the Krista McAuliffe Center for Integrated Science Learning at Framingham State, which is the home of the FSU Planetarium and of AstroNights. Our website is really easy to remember. It's cm-center.org. And for your convenience, we have put everything that will be most useful to you right here on our front page. All of the resources that will be useful to people who are learning at home right now, whether you're a student, a teacher, a parent, or anyone who wants to learn a little about our world, it's right there, and all things that are free and easy to use at home. We also have recently put up a button which takes you directly to a page we've always had, which explains how to make a donation to our center. Just like many, we've lost a lot of our program fees in recent months, and we would really appreciate your support. So everything that the FSU Planetarium has put together is under From the Dome to Your Home. And we encourage you to check this out. We've got some interesting resources, and everything related to AstroNights is here. So if you go to the AstroNights page, you will see that every program has its own page. Here's the program page for tonight, and this will continue to be up after the night's over. I mentioned some advice here about how to observe the Hercules cluster in your sky. Here's some advice on how to do it with binoculars. And then the robotic telescopes, that's Micro Observatory here. So Micro Observatory is a free online program that allows you to control robotic telescopes so you can take beautiful, high quality astrophotos of objects like Hercules. And that's one of their top objects right now. So we encourage you to check it out. And it's actually appropriate for all ages. All right, with that, I'm going to turn us back to the night sky and take a couple of questions from the audience. Okay. So, questions. I have a question. Are there any white dwarfs that we can see in the sky? That is an excellent question. Are there any white dwarfs that we can see in the sky? So this is a question about different types of stars. In the Hercules cluster, what we were seeing were a bunch of very old stars. And they're also very large. We know they must be pretty large because we can see them from Earth. White dwarfs are an interesting type of star. They're sort of, they may be old as well, maybe not quite as old, but white dwarfs are another stage in a star's life. They are very, very small, and therefore we really cannot see them. So there are places that we know there are white dwarfs, and they can be observed by very powerful telescopes, but they are much too small to be seen by our eyes and to be seen by any typical telescope. Okay, sorry about that. Okay, I have a question. Do you know why there is a cluster of stars? Okay, excellent question there. And I do know a little bit about star clusters. There's actually two types of star clusters. And you know what I might do? I might start my video again just so that people can see me while they hear my answers. So do you know why there is a cluster of stars? So I'm going to cheat on this question a little bit. I do want to tell you that there's two kinds of star clusters, and one of them is called an open cluster. And I'm actually going to go ahead and I want to tell you where all the clusters are, these open clusters. I'm going to label them. Okay, you should be seeing little green X's on my screen right now, or your own screen. Those are the locations of open clusters. I actually studied open clusters in college, and I do know the reason why they are in clusters, because when stars are formed, they're formed from big clouds of gas that collapse down and form stars. And you can imagine that these big clumpy clouds of gas don't usually just form one single star, they form many stars. So most stars are born together in clusters. It's really more common than single stars. But as you learned today, there is this other kind of cluster, which are globular clusters. And to be honest, we don't really know as much about them. I would say I definitely don't, but my research recently indicates that not many people know a lot about globular clusters, but they're a very interesting topic of study. So any prospective hopeful astronomers out there, especially any young people that are listening who might want to start solving some of the mysteries of the universe, there's a lot that we still need to learn about globular clusters. But now I'm going to, after I've rambled a little bit, I'm going to take another really simple answer to this question. And the reason why anything is together, the reason why stars are clustered together, the reason why clouds of gas is clumped together, the reason why anything is close together is because of gravity. So they're being held together by gravity, but how they really came to be in the particular orientation around the galaxy, we don't really know. Okay, anyone else have questions they want to put up? Questions? Okay, well, I have one more question then. And the question is, where in the galaxy would you like to visit? I assume that means me. Where would I like to visit? Where in the galaxy would I like to visit? The thing is, we don't know all that much about what exactly is out there in the galaxy. We know there's plenty of stars. We assume that they are some of them are similar to ours and probably have solar systems similar to ours, but we really don't know enough about them. If I could say I knew for sure that there was somewhere a star that had a planet just like Earth, where at the moment people were totally free to go out and do whatever they like on the planet, I would go there briefly and then come back here. But the thing is that a lot of people who study astronomy, like myself, are not super interested in going to visit anything because there really is so much that we can learn about the universe just by looking at the light that comes to us. So that's not why we study. We don't want to visit anywhere. We just want to learn. We want to learn what it's all about. And you can definitely do that without visiting. Okay. So I am going to wrap this up, but I do want to remind everyone to take a look at our website. And finally, if anyone did have a question that either didn't get answered, or maybe you would just wish that I would have gone on longer, we do collect all the questions, and someday we'll do a show all about the most popular questions that people ask us. All right, so I hope you all get some clear skies pretty soon, and have a chance to head outside and take a look at the real thing. So with that, I'm gonna stop and send you all on your way for a lovely weekend.